Okay, at the end of the last video, we had these 1, 2, 3, 4, 5, 6 problems. What I'm going to do is go through them, make sure that you got everything correct, and if you didn't, make changes in your packet. So the first thing we have in problem number 3, this is a linear pair because we have a straight line and we have 2 angles. So those I'm going to put LP next to for linear pair. And what we know about the linear pair is that they add up to 180. So we will say, since this is just 19 and there's no variable, we're just going to say 180 minus 19. And we can go over to Desmos and do that and get 161. Over here for number 4, those are, even though they're straight lines, these 2 angles, and I'm going to take a moment and highlight them because I want you to see, if you're not quite seeing the vertical angles yet, I want you to see the 2 different colors, how the vertices, the vertex is touching, but they are completely, it's like they're mad at each other. They're completely facing the opposite direction from each other. Okay, so they're both going to be the same. They're going to be the same size. So if this one is 19, then this one is 19. And the difference between problem 3 and problem 4 is that these angles are laying along a shared side right here. So you have this angle, and then when I draw angle 1, see how I draw that same side, and I get a yellow and a green on top of each other because they're sharing that piece. I hope that helps. Linear pairs and vertical angles pop up in just about every unit. So I want to make sure that you guys are getting a good understanding. Now in number 5, I'm not sure if you noticed, but there are both here. So I'll get my black pen in a minute and write that. But if you look, I don't know, maybe you saw the verticals first. So 72, and right here would be 72. Maybe you saw those first, or maybe you saw the linear pair first. So you have a straight line going this way, and 72 and angle 1 are sharing a side along that straight line. So we can figure that out. We can say, okay, well, that's going to be 180 minus 72 is 108. But then what's going to happen from here with angle 1 to angle 3 is we're going to have vertical angles again. So what you really have is you have vertical along this diagonal and vertical diagonally this way. And then you have actually 4 linear pairs. You have a linear pair here up above. You have a linear pair here down below. And then if you look here, you have a linear pair on the right. Angle 1 and angle 2 are a linear pair. And angle 3 and the 72 are a linear pair. So anytime that you see a situation like this, you're going to see it again in number 6. You're going to have 4 linear pairs and 2 pairs of vertical angles. Now, the only difference with, let me put both here, because that was a both problem. This is also a both problem. Now, if you remember, this little box means 90. So if you saw the linear pair first, then you said, okay, well, what's 180 minus 90? Well, that's 90, because 90 and 90 add up to 180. So there's a linear pair, but maybe you saw the vertical angles first and you said, okay, look, my vertical angles are running top to bottom. So I got vertical going from left to right, and I got vertical going top and bottom. And that should make sense to us simply because it's 90s. It's a little clearer. But also think about those 90s. I mean, that's sort of making a circular shape if we were to add all those up. And maybe some of you remember from, previous math that a circle is 360 degrees. So it's kind of making that circular shape. I like to use that comparison as well. Okay, now down here in 7 and 8, similar but different problems because they're asking us to find x. So what I'm going to do is go, okay, what kind of angles do I have first? So here I'm looking at the 40 and the 12x minus 8. Those look like number 4. Those are vertical. And I didn't write vertical angles here. I'm going to write vertical angles. And we know vertical angles are congruent or the same. So we can take 40 and set it equal to 12x minus 8. And if you don't want to solve that, I'm just going to grab a Desmos calculator real quick. 40 equals 12x minus 8. And you're going to get x is 4. Not too bad. And if you wanted to check it, you could plug it back in here. You could say, okay, what's 12 times x, which is 4? 12 times 4, well, that's 48. Minus 8 is 40. So we're getting 40 for both of these, and that's what we should have gotten. Now here, this is a linear pair because we have these two angles, and they're right next to each other, whereas these are not right next. They look like they're right next to each other, but they're just touching up their corners. These are fully right next to each other. They share that entire side. And so that's like problem number 1, where they add up to 180. Well, this time we have variables. So we have to say, hey, this first angle plus the second angle, and they're going to add up to 180. And maybe you don't want to solve that by hand. Maybe you do. Maybe it's quicker for you. I don't know. Usually my guidance is if you are getting your equations solved incorrectly, then just go on over and use the Desmos calculator. Now here I'm not seeing my answer, so I'm going to have to zoom out. There it is. And x is 10. So hopefully that gives you a little bit more work with the linear pairs and the vertical angles. That is on page 24. Now, looking at the bottom of page 24, you see that little exercise down below, and it goes from 41 to 50. And they all work off that picture. It looks like this. Let me switch to the next slide. So what I'm going to ask you guys to do is pause the video at this point. Take a try. See what you can do. If you want to buddy up with a buddy. Take about maybe 10, maybe 15 minutes tops, and then I want you to stop. Like after 15 minutes, if you guys are still struggling, stop, come back, put the video back on. If you're after 15 minutes just still working and making progress, then, I'll let Mrs. Hull decide what to do. But definitely don't go at this for more than about 10 or 15 minutes if everybody is lost. Okay, go ahead, pause the video. Okay, so I don't know how it went, but I'm going to go through it. Now, these first 4 problems are very misleading. And the reason that they're misleading is because of this right here, because they have the congruent sign. So let's just clear this up right now. Make sure we're all clear. Some of you might have put numbers in there and then wondered, hey, why is BGC in problem 41 and in problem 48? And then you got confused. So what they're doing when they say angle BGC is congruent, that means it's going to be congruent to another angle because it's an angle. So we want to look for BGC, and because it has a vertical pair, buddy, right here, that's what they're looking for. They're looking for angle FGE, or you could have said EGF. So I'm going to write this in. So they're actually looking for this. I'll call it FGE. I'm not going to put them both in there. Now, when you get the number for it, this little M right here, the measure of the angle, that's when they're looking for the numbers. Okay, so we'll get to that in just a minute. Let's take a look. First of all, let me erase. Let's take a look at AGB. Well, AGB, okay, cool. Let me grab that highlighter back. AGB is right there. And then it does have a vertical pair. So that's what we're looking for, a vertical angle buddy, because we know that vertical angles are congruent. So that's the easiest way to do this problem. So we're looking for EGD, or you could have said DGE. Pardon me. EGD. Okay. So then two more. Just erase real quick. And then AGC. Okay, so let's find that. AGC. That's a little harder to see, but I think it actually does have a vertical pair buddy. Let's see here. I'm going to get a different color. I think it's this one right there. That's really tough to see for some reason. I have a hard time seeing that. I think when I do that, I think I'm talking about the 22 angles, but I'm really talking about these bigger angles. So that's going to be angle FGD or DGF. Okay, that one was hard, I thought. Okay, and then lastly, and then we'll get into some numbers. So be patient here for just one more moment. So CGE. Oh, okay. Well, that has a vertical pair buddy. I don't think that's so hard to see. BGF. Okay. There we go. Okay, so now that we got the painful part over with, nobody likes that part, but I think it's important for us to continue to see those relationships. Now what we can do is we can actually use those relationships, because we know if they're congruent, then they're the same size. So let me grab, if this one's 50, this one's 50. If this one's 22, this one's 22. And then we have this last pair of vertical angles that we don't know. So what I like to do, and you might not like to do it, whatever. Not that I'm whatevering you, but it's okay. You know, I just want to show you how you can draw part of this picture, you know, just separate so that you can see. And what I'm drawing is this piece right here. And why am I drawing it? Well, because they're angles that are right next to each other, lying along a straight line. But this time, there's 3 of them, not 2 of them. So they still add up to 180, because this right here is a straight angle. So that's kind of useful information. So we know if we have 50 degrees here and 22 degrees here, and we add those up, that's 72. So we can use that to figure out that missing angle. And some of you probably did. You got 108. I like to fill these in first before I start answering these questions, simply because I think it just makes it go quicker. I don't know why. That's just my preference. You do not have to do it that way. But I feel like once it's all filled out and I know what all the different angles are, I can just pick them off. So if I look at AGF, let me see if I can get there we go, get a better pointer. Now I can't. AGF is 22. Go across here to DGE, DGE, that's 50. See, that's why I like to fill out the diagram first. Now let's look at CGE, angle CGE. Now, interesting, CGE is both of these. So it's the 50 and the 22. So I'm going to write over here 50 plus 22 is 72. Now let's look for BGC. Okay, so we already figured that out. See, that's kind of nice. We could just write 108. Let's look at DGF. Now D to G to F, let me make that red so we can see it. That's going to be all of this. So that's going to be the 108 plus the 50, which is 158. And then lastly, AGD. That's kind of a trick question. I'm going to erase everything real quick. Hang on a second. Look at AGD. Did anybody pick up on this when you were working in the group? AGD. That's 180. They're just trying to be tricky. Okay. So I hope between the work that you did in the classroom and then seeing this, thank you for tuning back in. That's really important that we get that closure on that. So now what I'm going to ask you to do is turn the page, the very last page in the packet. Yay, yay for us. To page 25. And at the top of the page, you're going to see this. And it's asking you to find X. It's asking you to find the measure of angle ABD. And it's asking you to find the measure of angle DBC. They're not asking for this. I've had a lot of kids do this over the years. That's not what they're looking for. They want just a number. They do not want an algebraic expression. So remember this, this is a linear pair. So let's just write that down here, linear pair. And they add up to 180. So I'd like you guys to take maybe just about 5 to 7 minutes or so. Excuse me, pause the video, give this a try, then come back and we'll go over it. Okay, so hopefully most of you guys remembered what we did back here, where we had linear pairs where the two angles added up to 180. So we're going to do that same thing again. We're going to do 4x plus 6. That's one part. 11x minus 6. That's another part. Equals 180. And you know, maybe you don't want to solve that by hand. So let's go over to Desmos. 4x plus 6 plus 11x minus 6 equals 180. And I'm going to get x is 12. So that's the first thing that they were asking me for. X is 12. Wonderful. Now they're asking me to find ABD. So if we look at the picture and just make sure angle ABD is 4x plus 6. Let me write x is 12 up here too. So we're going to take that 12. We're going to substitute or plug it in for x. 4 times 12 plus 6 will give us 54. 48 plus 6 is 54. And then if we do the same thing for angle DBC, that's obviously this other one, DBC. Kind of process of elimination there. That was the only one left. So plugging in 12 for x. Now that might not be so easy to do. So you might have to come over here to your Desmos. Let's see, minus 6. And that's 126. And how can you check yourself? Well, you can add these two up to see, hey, did I at least get 180? And I did. So that gives me a good feeling to know, and it's not a hard check to do because I can use the calculator. Okay, so last thing you're going to do, you're going to pause the video again. This is the very last thing on page 25. We will come back and talk about it, but I'd like you guys to all read what's happening here. They're talking about perpendicular. And remember, perpendicular is where the angles are 90 degrees. The lines, they cross at an exact right angle. So remember, a 90-degree angle, just gonna put a little red circle around that. So if PR, let me grab a highlighter real quick, and then I'll zip it for a minute. PR and SQ are perpendicular. Remember, you're going to have 90 degrees, but you're going to have, that's not letting me make it nicely. There we go. Let me erase this. There we go. You're going to have 90 degrees, 90 degrees, 90 degrees, 90 degrees. Okay, so what you're going to do is you're going to solve for X, you're going to solve for Y. So pause the video, see if you can figure it out. Take, maybe 10 minutes, see how that goes. And if everybody's getting frustrated, just come back and watch the video. Or if you guys are doing okay, but you want to, you should definitely come back and just take a look at the video so that we can make sure everybody's on the same page. Okay, well, I hope it went well. The first thing I'm actually going to do is solve for Y. And you might be wondering, well, why are you doing Y first? Well, if you look here, the 4y minus 2, that's the whole 90-degree angle. So this is actually a simpler problem than finding X. Because finding X, we have two angles. We have an angle here and an angle here. So we'll talk about that in a minute. So when I do 4y minus 2 equals 90, let me get rid of all this stuff from the last problem. I'm still going to use X, simply so Desmos handles it correctly. And I'm going to get 23 for my answer. So X is 23. Or, sorry, not X. X in Desmos means Y to me. Okay, so there we go. There's Y. Y is pretty straightforward. But now with X, you have to add the angles together. It's like part plus part equals whole again, where our 90 is our whole because these are perpendicular. Our STW, let me just erase that because I drew in there. That's 2x. And then 5x plus 6. So you have a part that's 2x. You have a part that's 5x plus 6. And that's equal to the whole, which is the 90. So again, I'm going to go over here. I was typing and it wasn't in there. There we go. Do that all the time. Equals 90 degrees. And I am getting, looks like 12 for my answer. Wonder if any of you guys got that. And that is X. And then if we wanted to know that it didn't ask for that, just wanted us to find X and Y. But if we did want to know, we could take that 12 and plug it in to both of them. 2 times 12, 2 times 12 will be 24. And then 5 times 12 plus 6, I think that's 66, but I can check it in the Desmos calculator if I need to. And then 24 plus 66 ought to add up to 90, and it does. So let me show you in the calculator. 5 times 12 plus 6, there's my 66. And my 24 plus 66 is 90. And I know the problem didn't ask you guys to do that. So if you didn't do that, that's totally fine. What I was trying to just show you here in the last couple of moments was that you can always take that little extra step using the Desmos calculator to check your answer. And sometimes that's helpful because then it just kind of clears any of your confusion up in your head. All right. Thank you very much.